Whoa, Jesus Christ.
Despite the negative depictions that have spread across mainstream media, hydraulic fracturing appears to be a major character in the next chapter of American policy and economics. Although hydraulic fracturing seems to be gaining attention from energy experts and environmentalists, very few details have reached the general public. Hydraulic fracturing is a 6-decade-old process developed in the late 40s, involving the breaking up of shale deposits deep under the ground using high-pressured water. The process of hydraulic fracturing has been revolutionized over the last few decades with the introduction of horizontal drilling. Horizontal drilling has dramatically increased the efficiency of natural gas wells. After locating a well, a drill bit generally 2 feet in diameter is used to drive 1.5 to 2 miles into the ground to reach the natural gas deposits, the equivalent of 8 Empire State Buildings. Once it has reached this point, the flexible drill turns horizontally and begins to drill across the deposit, maximizing the surface area of the well. After the well has been constructed, casing composed of cement and steel is laid down surrounding the steel pipes, protecting groundwater. This casing, mandated by state and federal law, reaches depths 200 feet below the freshwater zone. Now, perforating guns are sent down the well into the natural gas deposits. The guns fire, puncturing the steel tubing and fracturing the shale deposits. After the guns are retracted, a mixture of water, sand, and chemicals necessary to clean and lubricate the fracture points is introduced into the well. Due to the buildup in pressure, the water further breaks the shale, releasing gas. Under the weight of the earth above it, natural gas is injected into the steel piping and rises to the surface. There, the water and gas are separated, and the gas is ready to be shipped to locations across the globe.
There are several key concerns regarding hydraulic fracturing that have been raised by environmentalists, but they are hardly enough to warrant a moratorium on the industry as proposed by some. Groundwater contamination is a large concern for many people living near hydraulic fracturing sites. Methane leaks are a primary focal point for challengers of hydraulic fracturing. A high amount of methane in groundwater reserves can be dangerous, and is what makes things such as setting water on fire possible, as seen in our opening clip. What many people are unaware of is that a lot of groundwater already contains methane regardless of its proximity to hydraulic fracturing sites. While studies have shown increased amounts in groundwater reserves near gas wells, it is inconclusive where the methane is originating from. What can be shown is that the methane likely originated from further underground, but it is probably not the same doctored methane used in hydraulic fracturing because that methane is treated and meant to sink as opposed to rise. A highly probable scenario for methane in groundwater around the Marcellus Shale formation is that many old wells created over the last 150 years have not been properly closed off and are intersecting with new wells, the creation of which allows for the methane to travel to groundwater locations. If this is in fact the case, it certainly seems to be preventable with proper precautionary measures. Another issue is the high amount of water usage in hydraulic fracturing as well as the disposal of this water. It has been estimated that a typical hydraulic fracturing well can use between 2 to 8 million gallons of water. Through the hydraulic fracturing process, some of this water returns to the surface through flowback, and sometimes water from deep underground is brought with it. This deep water is different from the groundwater mentioned before. It is incredibly unsafe for human consumption as it can contain significant amounts of heavy metals such as arsenic. However, a properly maintained well will not have any issues with flowback explosions and flowback will be regulated. In the past, the disposal of wastewater has often been done by putting it underground, but studies have shown direct links between this process and seismic activity, the largest of which was a 5.3 on the Richter scale. This particular instance was unrelated to any hydraulic fracturing processes, however, and that method of wastewater removal is no longer employed. Wastewater is typically treated or recycled for reuse nowadays. Gas emissions have been another highly debated topic surrounding hydraulic fracturing and the continued use of natural gas. An important thing to note is that the natural gas recovered through hydraulic fracturing is actually much cleaner than the conventionally used natural gases, which has less to do with hydraulic fracturing and more to do with the gas itself. The release of methane is once again an issue, but compared to the increased cleanliness of the natural gas, there has still been an overall reduction in the amount of greenhouse gases released by the United States in recent years. In fact, the United States have been reducing emissions at a rate significantly faster than Europe despite their resistance to hydraulic fracturing. Even methane emissions decreased over 10% from 2005 to 2012.
Today, the United States exports comprise approximately 3.7% of the total distribution of natural gas exports globally, drawing numerical similarities to the likes of the Netherlands. Gas production in the U.S. is at an all-time high. Currently, shale gas specifically constitutes roughly 37% of the total U.S. gas supply. Therein, this increases the United States' production possibility for natural gas. Continuing to increase the extraction of shale gas from American wells would strengthen a domestic natural gas Denella Meadows-style system. This heightened production has led to an increasing propensity to export, rather than import gas, on the part of the United States. In 2005, oil imports in the United States declined from 60% compared to 42% in 2012. This standing places natural gas above nuclear energy, renewable energy, and even coal, which our country has shown strong dependence on in the past and even now, depending on location. 9.2 million jobs are already currently supported by U.S. oil and natural gas. It is predicted that shale gas alone could potentially support 1 million new jobs by 2025 and 1.6 million U.S. jobs by 2035. As of 2011, the United States possessed only 14 natural gas reserves. This is compared to over 70 natural gas reserves in Russia and approximately 148 gas reserves in the Middle East and counting. However, the Middle East's reserves are all but tapped. Our self-induced contention with Russia, coupled with the decline in the available reserves in the Middle East, has opened the door for the United States to move into place as a leading supplier of natural gas. If we were to reach production points where we as a nation were at our maximum propensity to produce, we could eventually reach zero imports as soon as 2037. Although this prediction involves several variables, it is still a possibility as shale formations in North Dakota, Texas, and now Pennsylvania, including the Marcellus Shale formation, are showing more promise than ever.
According to the Congressional Research Service, proposed U.S. liquid natural gas export projects, if all were constructed today, would make the United States the largest LNG exporter. Currently, Russia is the second largest exporter of natural gas to Europe, behind Norway. Due to this dependence on Russia for energy, many allies of the United States within Europe are unable to openly oppose Russia in global crises and talks. With the influx of LNG exports from the United States, the European energy market will be affected in two major ways. The first would be a major shift in the competitive balance between natural gas and oil. Almost all major exporters of natural gas and oil purposefully link and regulate the prices in order to keep both competitive with one another. The United States does not, however. With the inflow of cheaper American natural gas, this will put stress on the European oil market. Beyond stressing the competition between oil and natural gas, the introduction of imported American shale gas will also lessen Europe's dependence on Russian energy. This will play a key role in global conflicts, such as Syria and Ukraine. In a global climate with looming future issues, nations must approach problems with unslanted intentions.
Hydraulic fracturing will continue to be disputed as long as we as a society find flaws within the system itself. As discussed, the few problems and implications which do come with fracturing are far outweighed by the advantages that lie within it. The United States' attempted dependency shift from coal to natural gas has encountered some stumbling blocks along the way. Ultimately, a shift to natural gas is needed. The efficiency that hydraulic fracturing provides continues to outdo any other sustainable competition. Solar power, hydropower, and wind power are progressing, yet are not at the level we need them to be. It is predicted that in the U.S., fracturing would provide multiple stimulants to our economy through a boost in exports. Therefore, our foreign energy dependency could be minimized. When the subject of hydraulic fracturing is presented, the negative effects are what first are pointed out. Therein lies the problem. The minute issues which come with the fracturing process are being highlighted while the solutions it proposes have been drowned out. When comparing the benefits that come with hydraulic fracturing in the United States to the questionable environmental concerns and outcry, we must look to ensure the political freedom of our trade partners and our own energy prosperity.